Sir Isaac Newton is regarded as one of the greatest scientists of all time. He made discoveries of gravity, of forces in moving objects, light, and even invented calculus. He was born in England in 1643 and is really most famous for his laws of motion. Newton's first law is also called the law of inertia, and basically it just says that things keep doing whatever it is that they're doing. If something has a lot of inertia, it's hard to change whatever it is doing. Imagine a really large, heavy boulder. It's hard to get it to change its motion and start moving. It has a lot of inertia. Imagine a huge truck barreling down the road. It's hard to stop it and change its motion. It has a lot of inertia. But it's unbalanced forces that change the motion, and that is really what we want to look at as far as changing motion. So the first law states that an object at rest will remain at rest, but an object in motion will stay in motion until an unbalanced force affects it. An example of this is the seatbelt. You ever think about what might happen if you weren't attached to your car with a seatbelt and you got in a crash? Well, if you're going 60 miles per hour, you're going the same speed as the car, and everything else in it is going the same speed. And if it stops, then everything in the car is going to keep going that same speed unless it's strapped down. So why do you think you should wear your seatbelt? Here's a somewhat humorous graphic of someone driving a car, not buckled in, and hitting a brick wall. An object in motion stays in motion. What is Newton's second law? Well, the second law is F equals ma, and it's about how much force is needed to get something moving and in a certain direction. So mass is how much stuff something has, and acceleration is how its velocity is changing, so how its speed is changing. It's either going faster, slower, or changing direction. And Newton linked those together to say that if you push something, it's going to go in a certain direction that you push it with a certain acceleration. Let's think about infants sitting in the laps or in the seats of cars. Here's a picture of my daughter many years ago when she was still in attached to a chair in a car, and we covered her with stuffed animals. It was just fun. And there's a reason why you have to really tie down these chairs properly and keep kids safe. Even going at a low speed of like 30 miles an hour, the kid, if there's an impact, can accelerate with a great enough force to get up to 200 pounds or more. So that's just 30 miles an hour, and depending on the mass of the toddler or infant that's in the car seat. So these forces involved in a car crash are huge. And we can calculate these forces by using F equals ma, or a mass of 5 kilograms and an acceleration of 50, we get 250 newtons. And scientists and engineers have to use these calculations to figure out safety in cars. Now the third law states that for every action, there's an equal and opposite reaction. For every force, there's an equal and opposite force. And these two forces always work in pairs, and they work on different objects. And the best way to think of this, of course, is to look at a few examples. If you have a baseball bat and it's hitting on a baseball, not only does the baseball hit the baseball bat also hits the baseball, and they both accelerate. Another example, car on a road. The tire has to push on the road and the road pushes back. It's sometimes difficult to think that a road can push, but it does, and that's how it manages to move forward. In a rocket, you have an action force of the rocket pushing on the gas. The reaction is the gas pushes back on the rocket. That's what makes it go forward. That's what makes it work. So action and reaction forces always work in pairs, but they'll work on different objects.